In this video, let's take a look at the third traverse, called a closed loop back-to-back sight plus an angle. We'll open that traverse view up, and we can see that we started at point 21, but down here at point 25 we closed out on 22, which is the back sight, and then we turned an angle back to the initial point 21. We could have turned that angle to any other point in the survey, but we chose to use a point in this traverse. Let's bring up the drawing for that. Traverse PC draws it here for us, so we can see that we haven't closed out per se. We've just turned a closing angle back to our starting point. Let's bring up the closure view and see what Traverse PC has done with this information for us. So if we start up here in the Traverse summary, we see that we have a closed loop, so Traverse PC recognizes that even though we came back to the back side and not the initial point, it still considers that to be a closed loop and basically forces the closure across that last leg. Because it's a closed loop, Traverse PC computes an area for it. Next we have the closure summary. Now we close this out flat, and we can see that we have the same coordinates here on our closing point as we have for our backside if we go to the point view and look at that. But I want to show you that Traverse PC has also brought in the small angular error that we threw in at the end here. So we close out with a closing angle, and instead of 90 degrees, which would have closed out flat, we put just a small 15-second error in there. And that shows up here in the closure view for us as our angular error. And then finally, in the closing points, we see that we're starting at point 21, that we're ending at point 25, and the correct point for that is 22. And it picks that up out of the description here. So let's take a look at our closure settings. Just verify all that Traverse PC has done automatically for us here in this traverse. The closure type, it's set as a closed loop. The closing point, it's set as 25, and it knows that the correct closing point is 22 because we put that in the description. And then finally, it's brought in our closing angle and has established the correct bearing of the closing course as 22 to 21. We do that manually by typing in what it has already done, 22.21, and then it uses that difference to compute the angular error. So once again, Traverse PC has used the information we've set up in the traverse view to automatically set the closure type, the closing points, and the closing angle. We're using an equals 22 and an equals 21 here. We can enter this on just about any data collector, and the added benefit is that Traverse PC recognizes that equal as a redundant character when it does a least squares network adjustment. So it will treat this as a redundant observation 22 and redundant observation to 21 for the closing angle.